Hi everyone, and welcome to Geometry Lesson 5.2, Bisectors of Triangles. What we're going to be doing is we're going to be taking the things that we learned about in Lesson 5.1, perpendicular bisectors and angle bisectors, and we're actually going to be putting them into some triangles. But first, we have some terms to look at. The first term is concurrent. This describes lines that intersect at a point. So in my picture here, I would say that the green line, the blue line, and the purple line are concurrent lines. Now, the place where they all meet, this point is the point of concurrency. So it's the point where the three lines meet. Now, you could have 4 lines or 5 lines or 6 lines, but the point is the point of concurrency, and we would say that the lines are concurrent. Okay, so those are some important terms. Now let's take a look at our first special type of point of concurrency. Okay, the circumcenter of a triangle is the point of concurrency of the perpendicular bisectors. So notice what I've drawn in my triangle here is that we have a perpendicular bisector here with the red. Okay, it's bisecting AC and it's perpendicular to AC. Then I drew another one here at AB. It's perpendicular to AB and going to point C. And then I have BC here with a perpendicular bisector. Okay? Now, remember what we learned about perpendicular bisectors. If something is on the perpendicular bisector, then it's equidistant from the two ends of the segment. And that's what we call the circumcenter theorem. The circumcenter is equidistant from the angles of the triangle. So it's formed by bisecting the sides, so it's equidistant from the angles. Okay, the last thing that we need to know about a circumcenter is that it's the center of the circumscribed circle, and that's where it gets its name. See, circumscribed, circumcenter. That means that if I wanted to draw a circle that only touched the triangle at the vertices, the very corners of the triangle, then I would find the circumcenter and use a compass to draw a circle around that. Okay, it's the center of the circumscribed circle, the circle that goes around the triangle. Okay, the two most important things to remember though is that the sides are bisected and these distances to the angles are all going to be equal. So let's take a look at an example. In example 1, they've told us that KZ, LZ, and MZ are the perpendicular bisectors of the triangle. And they want you to use that information to find each measurement. The first one they want us to find is HZ. Notice that is a segment that goes to a corner of the triangle, a vertex of the triangle. So I look for another one that goes to a vertex that has a measurement, and that's the answer I'm going to say. So HZ is 19.9. Next, they wanted KG. KG is part of the outer segment of a triangle. It's the edge of the triangle, but it's only part of it. So remember, KZ is a perpendicular bisector, which means that this edge, HG, is cut in half. So if this side is 18.6, then this side is going to be 18.6. Next, they wanted JZ. Now, JZ is another segment that goes from the circumcenter to a corner. So remember, all of those are equal. So I just find another one that goes from the circumcenter to a corner, and that's my answer. So again, it's 19.9. And finally, they wanted GJ. Notice again, this is about the segment that makes up the side of a triangle. So remember, this side is cut in half. This half is 14.5, which means that this half is 14.5. And the total segment, I'd have to add them together or do 14.5 times 2. And that comes out to be 29. And that's my final answer there. So now you have one to try. In check it out number 1, we need to find CG, AD, and AB using this information. We're given that DG, EG, and FG are perpendicular bisectors of the triangle. So pause the video and do that, and then press play to see example 2. In example 2, they asked us to find the circumcenter of triangle RSO, and they gave us the vertices. R is negative 6, 0, S is 0, 4, and O is 0, 0. So step 1 is to graph the triangle. Always start with graphing the triangle. So I'm going to do that to get this blue triangle right here. So R is here at negative 6, 0, S is 0, 4, and O is 0, 0. Step 2 is to find the midpoint of 2 of the sides. And I always recommend using the vertical and horizontal sides because finding the midpoint is much easier. Please notice this side is 1, 2, 3, 4, 5, 6 boxes long. So I know the midpoint is right here at 3. And it's very easy to draw a perpendicular line to this because this is a horizontal line and perpendicular would be a vertical line. So the line I would draw for the perpendicular bisector would be right here. Then I would do the same thing for the other line. This line is 1, 2, 3, 4 boxes long. So to draw a perpendicular bisector to it, I would go 2 boxes up and then draw a horizontal line because that was a vertical line. So I have these 2 lines that I've drawn, and where they cross is going to be the circumcenter. Now remember, technically the circumcenter is the point of concurrency of 3 or more lines, but 2 lines can only cross at one point, so technically this point right here is my circumcenter. So I drew my perpendicular lines, and I found out that my circumcenter is the point negative 3, 2. And that's my answer right here, negative 3, 2. Okay, so now you're going to try it. And check it out, number 2, they've just given you different vertices. G is 0, negative 9, O is 0, 0, and H is 8, 0. So you're going to follow the same steps I did on that last example, and then you're going to watch the next video to learn about our next type of point of concurrency.